Torque, or sometimes called moment of force, is the tendency of a force to rotate an object about an axis, or pivot. Just as a force is a push or a pull, a torque can be thought of as a twist. Now Brent's going to demonstrate what torque is, and I'm going to do a little explanation. He applies the same force.
Hold on, don't move yet.
He applies the same force to one part of the door, and he'll apply the same force to the other part of the door.
Look at that distance.
Okay, now he's going to apply that same force. And the door opens more. This is because the equation for torque
Look at that distance.
is torque equals force times distance. And when you increase the distance, because distance is directly proportional to the force, it's going to increase the torque. So when distance is increased, it will increase the torque that is produced, therefore making the door open further than it would closer to the axis, because you increase the distance from the axis to the edge of the door.
Speed is a scalar quantity that refers to how fast an object is moving. Speed can be thought of as the rate at which an object covers distance. Hunter was moving 20 miles per hour right there. That was his instantaneous speed. Now, wait a minute and we'll show you what the acceleration is.
Alright, Hunter is going to accelerate from 0 to 20 miles an hour. 0 to 20 miles an hour. Alright, acceleration is
a vector quantity that is defined at the rate at which an object changes its velocity. An object is accelerating if it is changing its velocity. Velocity is defined as distance divided by time. Velocity is a vector quantity that refers to the rate at which an object changes its position. Hunter will show us that.
his velocity was just changed.
A projectile is an object upon which the only force acting is gravity. Many projectiles not only undergo a vertical motion, but also undergo a horizontal motion. That is, as they move upward or downward, they are also moving horizontally. There are two components of the projectile's motion, horizontal and vertical motion. And since perpendicular components of motion are independent of each other, these two components of motion can and must be discussed separately. The goal of this part of the lesson is to discuss the horizontal and vertical components of a projectile's motion. Specific attention will be given to the presence/absence of forces, acceleration, and velocity.
Now Brent is going to show you an example of a projectile, and it's going to follow a parabolic path into the net.
Swoosh.
He exerted a force upward / horizontally, and gravity pulled into a parabolic path through the net for splash. Now what that was an elastic collision. An elastic collision is defined as one in which both conservation of momentum and conservation of kinetic energy are observed. This implies that there is no dissipative force acting during the collision, and that all of the kinetic energy of the objects before the collision is still in the form of kinetic energy afterward. The balls were not changed in any way, and as soon as they hit each other, they bounced off and they were still moving. Therefore, the energy was conserved. Gravitational potential energy is the energy stored in an object as the result of its vertical position or height. The energy is stored as the result of the gravitational attraction of the Earth for the object.
Did you see me?
The equation for this is potential energy equals mass times gravity times height. Now what Brent is going to do is he's going to raise a 7 kilogram weight approximately 6 feet or 1.8 meters above the ground, and it is going to travel at 9.8 meters per second squared, which is gravity. This gives it a potential energy of 123.5 joules. Drop it. Now, as the weight was falling, that potential energy was converted into kinetic energy.
Go.
When a force acts upon an object to cause the displacement of the object, it is said that work was done upon the object. There are three key ingredients to work: force, displacement, and cause. In order for a force to qualify as having done work on an object, there must be displacement, and the force must cause the displacement.
Now, I'm going to do work on this object. This is a weight. And what's going to happen is, I'm going to lift the weight, and I'm doing work on the object. Now, the faster that I pick it up, there's no extra work doing on it just because I moved it faster. However, the power is increased.
And you want to know why the power is increased?
I do.
Okay. The power is increased because power is defined, or the equation for it is work divided by time. So,
The faster I move it, there's more power. Now, I can sit with this weight, and I can walk across the room horizontally. There's no work being done.
On the object.
On the object. There's no work being done on the object. Now, there is when it's vertically. Work is only exerted when it's vertically. Horizontally, there is no work.